Hi everyone and welcome. My name is Kevin Forrester and this is Tutor Kev Lessons. Today I would like to continue on with our Quadratics series, and if you haven't seen any of my previous videos, please take a look at the pop-up on the left and join from the beginning of the series. Today I would like to take a look at simultaneous quadratics, which follows on quite nicely from quadratic equations and algebraic fractions that I covered in the previous two videos. So let's dive into the simultaneous quadratics. Right, so solving quadratics simultaneously is the next section, and when you hear of simultaneous equations, you need to make sure that you understand that this relates to finding points of intersection between two curves, or finding points of intersection between two straight lines, or finding points of intersection between curves and straight lines. So simultaneous equations equals points of intersection. In the exam, they generally like to ask, find the points of intersection between such and such, and it requires you to do simultaneous equations. So it's really good to have some sort of insight as to what are they asking you as the person who's going to be writing the exam ultimately. So let's take a look at two questions. The first one being a nice simple one where we can just apply some general rules, and then we're going to look at a more difficult one where we can use what we learned from the first example. So my first example is the following. I've got a straight line, y equals to 6 minus x, and a curve, or a parabola in this case, y equals to x squared. Now generally the first thing you want to do is you want to make a variable the subject of the formula, or the equation. Right, and what that means is you want to have just a lonely y or a lonely x or just some lonely variable on the one side of the equal sign. And if you notice in this example, we have two. Both the y's are subjects of their respective equations. So this is going to be quite a nice, quick and simple example. So the second thing that we do is we substitute into the other equation. And solve. Okay, now when we're dealing with quadratic simultaneous equations, we will get most 2 points of intersection. So expect to get two solutions when you're solving these. So here I'm going to now substitute in this term, this x squared, into this y. So I'm going to get x squared is equal to 6 minus x. And here we've got a quadratic, and we know how to solve quadratics. We need to make it equal to 0 and then factorize. So I'm going to take everything to the other side. So it's going to be plus x and minus 6 equals to 0. And then I factorize x and an x. And I know that the factors of minus 6, we've seen this one a couple times now, it's going to give me plus 3 minus 2, and those combined will give me a plus x. And so my solutions will be x equals to minus 3 and x equal to 2. Now, once you have found your solutions for x, you need to substitute back into your original equations to then determine the values for y. So therefore, y is equal to minus 3 squared, which is equal to 9. And then I also get y is equal to 2 squared. So y is equal to 4. And those are the solutions for this pair of equations. What I like to do is write these as solution pairs. So I'm going to have a minus 3 and a 9, or 2 and 4. And those are my answers to this pair of equations. Let's take a look at a more difficult example and apply these rules that we've just learned now. Right, so here is my more difficult example. So we've got 2y minus x is equal to 5 and 2x squared minus 3y squared equal to 15. Now, if you feel that you know what to do, I suggest pausing the video now and then giving it a shot and then unpause when you feel that you're ready. Right, so step number 1, what we need to do is make one of the variables the subject. Now, I like to always try and manipulate the linear equation, so the one without any squares, because you don't want to be dealing with any square roots that might come from making a variable the subject when you're dealing with the quadratic. So let's manipulate the first equation. So here we can see that we've got this lonely x. So I'm going to take that to the other side and then take the 5 over, and then I'll have x as the subject of my equation. Right, so I've added x to the other side, and now I'm going to subtract by 5. So that's going to give me 2y minus 5 equals to x. So here I have 2y minus 5 equals to x being the subject, and 2y minus 5 is what I'm going to substitute in for the place of x in the other equation. So therefore, I'm going to use brackets. So I'm going to have 2y minus 5 squared minus 3y squared equal to 15. And here I'm going to then write my brackets twice, FOIL, expand, simplify. Notice that I have a quadratic, so then take everything over to the other side and then factorize. So I'm going to have 2y minus 5, 2y minus 5. I generally tell my students to do this if they're not feeling super confident in working with squared brackets. This is just a nice safe way to make sure that you FOIL correctly and don't leave out any terms. So we're going to have minus 3y squared equal to 15. Right, from here we FOIL. So we're going to have 4y squared minus 10y plus 25, close bracket, minus 3y squared equal to 15. Then we multiply in the 2, so I'm going to get 8y squared minus 20y plus 50 minus 3y squared, and I'm going to take the 15 over as well while I'm at it. So I'm going to get minus 15 equal to 0. Now that I've done this, I need to simplify. So I'm going to get 5y squared, because 8y squared minus 3y squared gives me 5y squared, 20y, it's going to give me minus 40y. And then I've got 50 minus 15, which gives me plus 35, and that is equal to 0. Now, instead of just factorizing straight away, we can see that all of these terms are divisible by 5. So I'm going to divide every single term by 5 to simplify my equation even further. So I'm going to get y squared minus 8y plus 7 equals to 0. Now that I've simplified, I'm going to factorize, and we can see that we've got 7, which is a prime number, and it's only got 2 factors, 1 and itself. And so if I have minus 7 and minus 1, those multiply give me plus 7, and those added give me minus 8. And so now I've fully factorized, and now I can solve for y. So y is equal to 7, or y is equal to 1. Right, so now I've found my values for y. Now I substitute back into my original equation, and I'm going to use the one that I substituted in originally, because then I'll get x immediately. So therefore, x is equal to 2 times by 7 minus 5. And so I'm going to get x is equal to 14 minus 5 is 9. And then my other one is going to be x is equal to 2 times by 1 minus 5. And so therefore x is equal to minus 3. And then again, I'm going to write my answers as number pairs. So I'm going to have 9, 7, or minus 3, 1. And those are my solutions for my quadratic simultaneous equations. I hope you guys found this helpful, and I hope you guys managed to learn a little bit more about how to solve quadratic equations or simultaneous quadratic equations. If you have any questions, please feel free to leave a comment in the section below. I'll try and answer it in a future video. If you like this video, please a thumbs up would be amazing. And if you really like this video and you like this channel and like what we're doing here, a subscription to Forest Tutoring would be really appreciated. I hope to see you guys in the next one. Cheers.